For the first tutorial this week, we're going to create a simple set of stairs inside the pavilion. And we'll explore a few construction techniques using the construction planes and talk about good ways to organize your work as we go. So this is what we're going to be creating pretty quickly, this sort of stair as an extruded solid. I'll delete that, and I will also hide everything except this back mezzanine that we'll want the stair to go up to. So to hide everything, I will go to Select. I'll select all the surfaces except for that one, and I'll hide those. And you can see I still have the profiles, which we'll hide in a minute, but those were drawn on the right, in the right-hand view, with the construction plane oriented that way. Notice that in perspective, you can see the grid here shows that the construction plane is set to the XY plane. And so that's not going to do us any good to be drawing that way. I have a few choices. I could set the C plane. I could set it to the world front. And so I could draw with that as the construction plane, but all the geometry that I draw would be out here toward the front end of things. What I really want to be doing is drawing back up against this wall. And to make that easy, what I'm going to do is create a custom construction plane. So I will go to the C-Planes tab, and I can use the Set C-Plane to Surface. I can select the surface that I want, and then it wants to know what the origin of the new construction plane will be and in which direction the X axis will be. So now you see the construction plane here set with its origin on that corner, with the Y straight up, with Z, pardon me, with the Z straight up and the X to the right. And I can draw very nicely on that construction plane. So I'm going to hide a little bit more. I can just type hide and click on these curves. And now I can zoom in here and I can start to draw. And in this case, I don't need to be looking at it flat in order to be able to do this. So I'll start again with a bit of construction geometry. I'll draw a line segment vertically on the edge of this wall. I could also extract a curve from there. But I've got that, and that's all I really need now to build with. So I can even take that and hide it. And to make a set of stairs here, we need to come up with the proper number of risers. The rule for risers on a stair for a commercial building is that they need to be no more than 7 inches in height and no less than 4 inches in height. For a residential project, for a house, you can have risers that are higher, up to about 7 3/4 inches. But let's say that we need to take this 9-foot curve. We can find out how long it is by using a distance command, but this was constructed as a 9-foot vertical surface for this mezzanine. And we need to divide that into equal spacing that will be less than 7 inches. So I've done a bit of math, and I know that if I take this and divide it into 16 risers, or 16 equal divisions, each one will be 6 3/4 inches. So I can click it, I can say divide, and I can tell it that I want it to be divided into 16 equal spaces. You can also divide something by length, but in this case we want it to equally divide. And so now I can see a series of points that show the divisions where each of the risers will be. The rule for the depth of treads, the part that you step on a stair, is that they should be around 11 inches, perhaps longer. And in fact, as your risers get shorter, the treads should get longer in order to accommodate the human gait. And a very good rule of thumb is that if you add 2 risers and 1 tread, that should come to somewhere between 26 and 27 inches. So 2 risers at 6 3/4 equals 13.5 inches. That means to hit 26, we need at least 12.5 inch treads. We could make them 13 to round that up a little bit. So what I'll do now is I'll create a single polyline that represents one tread, one riser and one tread. So I'll come up to the first point, which I know is 6 3/4 inches. I'll hold Shift and I'll come over 13 inches. Make sure to type inches and hit return. I've now created one riser and one tread, which is the basic unit for the stairs that I'm going to be creating. I can take that now and I can array it, and I can put that anywhere here that I need to. And so we know we need 16 of these, 16 risers. So I'll take this and use an array command. You probably are familiar with making arrays. You can make a gridded array. You can make a polar array in a circle. You can array along a curve. In this case, we're going to do a linear array. And we'll tell it that we want to have 16 copies of this. I'll move this over before I do so it doesn't run over my other geometry. And I'll redo the array linear 16 times. And we have a series of polylines that we can add more geometry to in order to create a simple concrete cross-section for extruding to make the stair. So what I'll do is I'll draw a series of line segments, a horizontal one, a vertical one, and I can draw a diagonal line that follows the slope of the stair, and then offset that by 6 inches or 0.5 feet. It's already input in my offset command. And I can then trim the ends of these curves to make the stair enclosure, and delete this first input line. And then take all of those lines, join them together into a single enclosed polyline, and I can take this now and I can make a solid using extrude planar curve straight. I can make this 5 feet thick, and I have a pretty quick and useful stair. I could get rid of this geometry that I used to create it, and I can show all of the pavilion parts that I created before. I can take the solid stair itself and move it now into position at the corner of this mezzanine. And I see its profile there. I could come in and take that profile. I could delete it. I can always recreate that geometry from the solid itself. And so we've created a simple stair. And we've learned about moving the construction plane, as we did, you can still see it here below, to a surface that we wanted to use as a reference surface. That construction plane, if we want to keep it and save it for later, it might be useful for us to have a construction plane on that surface. It's easy enough to make a new one, but we can also always save a construction plane for future use. So I can click on Save C-Plane by name, and I can give it a name. It suggests C-Plane 1. I can call it stair, and I can retrieve a named construction plane to be used later. I can also go back to the one that I started with, or at any time I can go to, by right-clicking the view that I'm working in, I can set the construction plane to any of the world axes that we want. I can set a new one, as we did before, with 3 points, etc. So if I go back to world top where it was, you'll see that it's now on the XY plane, is the construction plane that's active for this view. So that was a quick stair and a little bit of an introduction to the use and manipulation of construction planes. Remember, whenever you're drawing geometry, unless you're snapping to endpoints of other geometry, you're going to be drawing on whichever construction plane is the one that is active, and you can control that by view. If you go to the front view, you'll be drawing on this construction plane in the front, or whatever has been chosen. The top view has the XY plane, and right now perspective also has the XY plane, but I could change that to a different construction plane orientation using the set C plane. And I could set it, oh, here are my named ones. I could set it to stairs, and have it go back where it was, I can right-click, set C-plane, and I could go back to world front to have it come here to the front edge of the pavilion. All right, we'll make another stair in the next tutorial.